Hi, I'm Maciej, and this video belongs to the series presenting my idea to use Mathematica for formal methods. You have already seen that Mathematica notebooks can be used as technical documents that describe and define the system and its internal structure. And we have already defined the empty system. I have shown you that the association as a universal data structure can be used to store different properties, internal properties of the system. We have defined a set of packages. This set was flat because there is no need to think about the package hierarchies at this stage. We can evolve this concept later. However, it's clear that we will need some way to define further entities to provide the detailed description of our system. So as you can expect, and as you know from other programming languages, we will need some way to define types, objects, and operations. We will start with types. And I believe that these are the most useful, although still very basic and fundamental, classes of types. Okay, so we should have booleans to represent truth values. We should have enumerations, some numeric types, arrays, and structures as a way to define aggregates. And in some systems, booleans are treated as a special case of enumeration, or maybe booleans and enumerations are treated as special cases of numeric values. But I think that such simplifications, even though they can reflect some low-level properties of the implementation, they are not very useful at the modeling level, and I would like to keep them distinct. So let's say that the Boolean type is already present. It's built in, there is no need to define it. So I will show you a possible way to define the enumeration type and how it can be stored in a data structure that describes our system. Okay, so this is an empty Mathematica notebook with some expressions which I have already typed. This will load the FMT package. Okay, so it's done. And this expression creates a new but empty system. So now sys is a symbol that refers to the data structure. It's an association object with basically empty fields because our system doesn't have any definitions yet. What I've done now is that I have created a package named A, and the information about this package was introduced into the data structure denoted by sys. But now I will define my first enumeration type. Okay, so there is a function define data types, and the arguments to this function are the name of the system, the data structure that defines the whole system, and the name of the package where I want to define my enumeration type. This function can be used to define multiple times in a single invocation, but I will define just one type. Let's call it a state, and we will simply have two values of this type, on and off. The enum is the wrapper that will be recognized internally by the by FMT. So I execute it, and now my definition of the state enumeration type was introduced to the system. I will define two more enumerations using the same convention, but I will benefit from the possibility to define multiple times in a single go. So let's say that I have simple colors enumeration, and maybe some signal states. Okay, let's suppose that we are dealing with embedded systems and we need states like this: low, high, and high impedance. Okay, done. So we can inspect the internal properties of the system data structure. Normally this is not needed, but just for the sake of presentation on how Mathematica can be used to store such definitions, I'm showing this. So I have a field package types, and I have three types in a package A, okay? And I also have type definitions for these enumerations. These are already stored in a data structure and can be used whenever I will refer to these enumerations in my operations, or maybe when I will want to define data objects of these types. The FMT package will be able to check whether the symbols are proper for these types. So that's it. This is perfectly sufficient to define enumeration types in a simple data structure and to associate them with chosen packages. In the next video, I will show you how numeric types can be defined. Thank you for watching.